When you look out into the cosmos, some galaxies just seem simple. They're the quiet ones, the ones astronomers thought they had all figured out. Well, today we're pulling back the curtain on one of these so-called fossil galaxies, the giant elliptical, Messier 60. So let's take a trip. We're heading about 54 million light years away to the Virgo constellation. See that big fuzzy blob on the left? That's M60. In regular visible light, it just looks like a peaceful, cosmic puffball, right? For decades, that's what we thought it was. A massive collection of old stars, a fossil whose best days were long behind it, a quiet relic. But as we've learned time and time again in astronomy, things are almost never what they seem on the surface. What if this calm, fossil-like appearance is actually hiding a much more complex and maybe even violent reality? To start unraveling this mystery, we have to look beyond what our eyes can see, because the first major clue is hiding in the galaxy's invisible, ghostly atmosphere. And this is where modern astronomy gets really cool. We have telescopes that can see the universe in all sorts of different wavelengths of light, like X-rays. And by using these different eyes, we can uncover cosmic structures and processes that are otherwise completely invisible to us. And wow, does this drive the point home? On the left, there's that calm optical view we saw before, but on the right, that's Messier 60 as seen by the Chandra X-ray Observatory. All of a sudden, this quiet little fossil is glowing, enveloped in a vast halo of superheated gas. It's a completely different object. So here's the key thing to get. M60 isn't just a ball of stars floating in empty space. Nope, it's sitting inside this enormous, hot atmosphere that we call the interstellar medium, or ISM. This gas is millions of degrees, so hot it glows in X-rays, and it holds some vital clues about what this galaxy is really up to. Now, what's really fascinating when you look at this X-ray image is that the gas isn't perfectly smooth. It looks disturbed. You can see these features almost like giant holes or bubbles have been carved right out of it. And that begs a pretty serious question. What kind of engine is powerful enough to do that on a galactic scale? Well, to find the source of that immense power, we need to look deep inside the galaxy's engine room, its very heart. When we zoom in on that X-ray data, astronomers found these massive cavities, huge regions where the hot gas of the interstellar medium has been violently blown aside. This isn't some ancient history. It's clear evidence of a powerful force at work right now. And really, there's only one thing we know of that can unleash this kind of biblical-scale energy from the center of a galaxy, and that's a supermassive black hole. It turns out Messier 60's core has a beast that is actively shaping its entire environment. When a supermassive black hole is actively feeding on gas, we call it an active galactic nucleus, or AGN. This is the galaxy's powerhouse. It's not just sitting there doing nothing, it's a dynamic engine that can release more energy than all the billions of stars in the galaxy combined. So, how does this actually work? It's a process called AGN feedback. As gas spirals down toward the black hole, not all of it makes it in. A crazy amount of energy gets released, launching these powerful jets of particles away from the black hole at almost the speed of light. These jets then slam into the interstellar medium, plowing the gas out of the way and inflating these enormous cavities, kind of like blowing bubbles in water. Okay, so we've got a hidden atmosphere and a powerful engine. But the investigation doesn't stop there, because when astronomers looked at the stuff this atmosphere was made of, they found another even deeper puzzle. All right, check this out. The gas cloud around M60 should be full of heavy elements, things like oxygen, iron, silicon, stuff astronomers just call metals, that were created inside M60's own stars over billions of years. But when they actually measured it, the gas was surprisingly diluted. It had way fewer heavy elements than it was supposed to. The only way this makes any sense is if M60 isn't some isolated, closed-off system. It has to be actively pulling in fresh, less enriched gas from the space around it. This new gas is mixing with the old stuff and watering it down, solving the puzzle. This so-called fossil galaxy is actually breathing. And this idea just completely flips the script on how we think about galaxies like M60. As the researchers Loewenstein and Davis put it, they're open ecosystems. They are constantly interacting with their surroundings, trading material back and forth in this dynamic, ongoing cycle. The fossil is alive and well. So we have a hidden atmosphere, a central engine, and we know it's breathing. But there is one more secret, and frankly, it's the biggest one of all. It's not about what we can see, but what we can't. See, one way you can weigh a galaxy is by measuring how fast its stars are moving. The faster they're going, the more gravity, and therefore more mass you need to keep them from flying off into space. Well, when astronomers clocked the speeds inside M60, they found a huge problem. The stars were moving way, way too fast. First, they did the math on everything they could see. Every single star, all that hot gas in its halo, the whole shebang. The grand total came out to about 600 billion times the mass of our sun. A huge number. But it wasn't nearly enough. Based on how fast everything was moving, the total mass needed to hold M60 together with gravity is about 1 trillion solar masses. That's a shortfall of 400 billion suns. 40% of the entire galaxy is just missing. So where is it? The answer, of course, is dark matter. This is that mysterious, invisible substance that doesn't emit or reflect any light, which is why we can't see it. But it has gravity, a lot of it. It forms this vast, unseen halo, an invisible skeleton that provides the extra gravitational glue needed to hold the whole galaxy together. So let's just put it all together for a second. That simple, fuzzy blob we started with is anything but. Messier 60 is not a fossil. It's a dynamic, breathing ecosystem. It's powered by a central black hole engine that's literally carving holes in its own atmosphere. It's constantly exchanging material with the space around it, and the whole thing is built on an invisible foundation of dark matter. We went from a simple picture to one of incredible, hidden complexity. And it just leaves you with this final thought. If this is what we find when we look closely at just one supposedly quiet, simple galaxy, what other secrets is the universe just waiting to show us?